Section 4.2 is about quadratic equations and inequalities. Before we begin on that, we are going to review a little bit of algebra. We are just going over this in the second trimester of algebra, and it's been a couple years since you've had that, so let's go ahead and review how we complete a square. If we can get an equation on one side of the equation to look like this, in this form, and have an x squared term and an x term, we can follow these steps in order to complete the square. We can find 1/2 of b, so 1/2 of whatever number this is, so half of that thing, and then square it. Then all we have to do is add that number to both sides of our equations, and we can solve by completing the square. Let me go ahead and show you, give you an example here, and that'll make much more sense to you. So it says solve by completing the square. First of all, we have to get it into where it had a squared term and just a normal term, so we're going to subtract this 3 over. So I'm going to have a squared minus 14a, and when I subtract it over, I'm going to get negative 13 over here. All right. So the completing the square says to find half of this, which would be 7, and square it, which is a positive 49. And what I need to do is I need to add that to both sides. So plus 49, whoops, forgot my 4, equals negative 13 plus 49. Since I added it to the left side, in order to keep my equation balanced, I need to add it to the right side as well. What this does now is this makes this left side a perfect square. Would you agree that this is the same thing as a minus 7 squared? All right, if I would go ahead and FOIL out a minus 7 times a minus 7, I'm going to get a squared minus 7a minus 7a plus 49. All right, so when we complete the square, we're always going to get this side to be a perfect square like this, so a minus 7 squared. And that is going to equal, let's see, 49 minus 13, which is 36. And then in order to solve, solving becomes easy when we take the square root of both sides to get rid of that squared sign. So a minus 7 equals the square root of 36, which is plus or minus 6. And when I add 7 to both sides, a equals 7 plus or minus 6. So a is going to equal 7 plus 6, which is 13. So a equals 13. A is also going to equal 7 minus 6, which is 1. All right. So that's another way of factoring things. We've shown you a couple ways from that last test to factor. So here we go. It says solve by completing the square. Again, we're going to want this to be just the x squared and the x by itself on one side of it. So if I go ahead and move these guys over, we'll solve. So let's go ahead and let's move each of these guys over to the other side. So I'm going to have, let's see, I'm going to have positive 10 x squared plus 50x equals 1500. We can also, actually, we could divide a 10 out of each and every one of these and make our numbers a little bit easier. So we're going to have x squared plus 5x equals 150. That might make things easier. So let's complete the square. All right, so that means we're going to take half of this guy, which is 5 halves, and we're going to have to add to it 5 halves squared. So half of 5 is 5 halves, and when we square that thing, we're going to have 25 fourths, or 6.25. That would be 6 and 1/4. So we would have x squared plus 5x plus 25 fourths, or 6.25. And since we added it to the left side, we have to add it to the right side. All right. And then again, we know every time we complete the square like this is going to become something squared. And what it becomes half of this guy. So it's going to be x. In this case, it's going to be plus because of this plus sign. X plus 5 halves, or 2.5 squared, equals 156.25. And then again, to solve this, we'll take the square root of both sides. So we'll have x plus 2.5 equals the square root of 156.25. And then all we have to do is subtract our 2.5 over. X equals negative 2.5 plus or minus the square root of 156.25. And that's all we have to do. Then, of course, we could take the square root of 156.25, and we get roughly 12 and a half. So we'll have x equals negative 2.5 plus or minus 12.5 when I take the square root of this guy. And then negative 2.5 plus 12 and a half, we'll have, so x equals 10. And when we go negative 2.5 minus 12.5, we'll have x equals negative 15. All right, so that's a little bit of algebra review for completing the square that can come in handy when we're trying to solve quadratic equations. Another thing that can come in handy is called the quadratic formula. Again, you've had this in algebra, and I expect you to know this stuff, but just in case, we'll go over it so we can review it. The quadratic formula for any quadratic equation that's in the form ax squared plus bx plus c equals 0, so we're solving it to be equal to 0. We want to solve for when x equals 0. We're going to use a quadratic formula. It's the same thing. We can factor, we can complete the square, we could use a quadratic formula. And the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. And I have a nice little song to help you remember that. It goes to the tune of Pop Goes the Weasel. It goes negative b plus or minus square root of b squared minus 4ac all over 2a. All right, that's just a silly way and how I remember how to remember the quadratic formula. Doesn't work for you, it doesn't. That's no big deal. But that's how I remember it. We can use a quadratic formula to find the roots of any quadratic equation. All right, that'll tell us. It'll solve for when x equals 0, and we know that a root is when x equals 0. So when does the graph cross the x-intercept? Where is this x-intercepts at? And that's, sorry, when y equals 0, my bad. So where is it, where it has its y-intercepts, where it has x-intercepts, where y equals 0 is going to be our roots. So just because I messed up so many times saying that, I'm going to draw a picture real quick and say that here I have two roots right here. Where y equals 0, we're looking for the x-intercepts. Okay, so one more thing to talk about quadratic equations and functions. You all know that they're a parabola because it's an even-powered thing. And quadratic functions are parabolas, and they will have symmetry, and they actually have a special line that is symmetric to, called the axis of symmetry, where they can fold in half. And it's very easy to find the axis of symmetry. It looks very similar to our quadratic formula right here, negative b plus or minus square root of b squared minus 4ac over 2a, except for it just takes out the square root part. And this right here will tell us exactly where the axis of symmetry is. And then we can go ahead and graph that thing easily. And also in big, bold, capital letters might mean you want to write it down. The axis of symmetry will always be the x value for your vertex. So we can always find the vertex of our graph, and thus making it easier to graph that thing as well. So this section is all about finding all those things and graphing. So here we go. So this example 3 says, find the roots of 4x squared minus 8x plus 3 equals 0, then graph the function. All right, its roots, its x-intercepts, where y equals 0. So maybe they, instead of just putting equal to 0 there for you, maybe they just would have said graph y equals 4x squared minus 8x plus 3. Maybe they just said graph. Well, to graph it, we can do a bunch of things that are going to help us out. First off, let's find the roots. Where does y equal 0? So that's why they set it equal to 0. Well, we have two options. We can factor it if we want to. We can use a quadratic formula if we want to. For case of review, I'll show both of you, both the options. I'm going to pause this quick so I can plug in my writer quick. All right, let's start off first. Let's factor this thing. I showed you guys this the other day, but we'll work on it again. So when we factor a quadratic formula or a quadratic equation that has something bigger than 1 right here, we had to do a different step that you're used to. We didn't want to guess and check the whole time by breaking and go ahead and write in 2 parentheses like this already. We didn't want to do that, so I showed you a way that took out all the guesswork, and we'll show you that example again. So let's go ahead and let's multiply 4 times 3. So you multiply the last 2 terms, and that is 12. So our options, what we're going to do is we're going to replace this middle term with something that multiplies to be 12 and adds up to be negative 8. This sign always, if it's a plus, tells me that the signs are the same. And this sign, since they're the same, they're both going to be minus. If this is a minus sign, it meant the signs are different, and this sign would tell us which one the bigger one is, the bigger number is. So in this case, the signs are the same. So what multiplies to be 12 and adds up to be negative 8? We have options for multiples of 12. We have 1 and 12, 2 and 6, 3 and 4. Okay, and we said they're both going to be the same, and they're both minus signs. So out of those, which ones add up to be a negative 8? Well, this one does right here. And remember, all we did is we replaced this negative 8x. So I'm going to have 4x squared, and instead of this negative 8x, I'm going to have minus 6x minus 2x plus 3. And all I did is replace, because negative 6x minus 2x is negative 8x. All right, and the step after that says we were going to group them. And we're going to pull out common terms. So what I can pull out of here, I can pull out a 2x. If I pull out a 2x, I'm left over with 2x minus 3. And then here, I have to get this to look the same as this. So what I have to do is I'm going to have to pull out a negative 1 is what I'm going to have to pull out. That'll make this a positive 2x minus 3. So when I factor this thing out, I have 2x minus 1 and 2x minus 3. So what I did now, because these guys are the same, I can pull out a 2x minus 3 and write what's left over in a parentheses, 2x minus 1. And if we're solving for when y is 0, we just have to set each of these parentheses equal to 0. So I'm going to have 2x minus 1 equals 0, and 2x minus 3 equals 0. So I'll have, in this case, I'll have x equals 1/2. And x equals 3/2. So there's where I'm going to have roots. I'm going to have roots at 3/2, which is 1 and 1/2 there. And I'm going to have one at 1/2, which is right there. And that's going to help us graph this thing. Okay? So let me go ahead and show you another method. And then we talked about the quadratic formula work out the same way. All right, so let me get rid of these guys quick here. Get rid of my factoring. All right, so let's get rid of that and let's use the quadratic formula. The quadratic formula says that it's negative b, so the opposite of the b value, so this would be positive 8, plus or minus the square root of b squared, so negative 8 squared, which is 64, minus 4 times a, which is 4. This is my a value here, so it goes a, b, and it includes the signs, and c. So minus 4ac, which is 3, all over 2a. 2 times 4, which will be 8. So let's go ahead and let's simplify inside of the square root first. So we're going to have 64 minus 16 times 3 inside that parentheses. So we're going to have 48. So we have 8 plus or minus the square root of 64 minus 48 all over 8. 64 minus 48 is 16. So 8 plus or minus the square root of 16 all over 8. Square root of 16 is 4, so I have 8 plus or minus 4 all over 8. And in order to solve, I go 8 plus 4, which is 12 eighths, which would be the same thing as we take a 4 out of each of them, 3/2. That's what we got last time, so that's good. And then we go 8 minus 4, which is 4 divided by 8. And that's 1/2, which is good. We got the very same thing as we did last time. Again, it doesn't matter which way you do it. As long as you can get it factored, as long as you get it correct, I don't care. So we got the same thing we did last time. So there are roots. They asked us to find our y-intercept. Well, that's going to help us graph. Any information is going to help us graph. Our y-intercept is simply where x equals 0. So plug in 0 for x. So I have a y-intercept at 0, 3. Right there. And the last thing is to find the vertex. We talked about that in our notes. The vertex is going to be where we want to find its line of symmetry. So our line of symmetry is negative b, so a positive 8 all over 2a, which 2 times 4. And that is 1. So our vertex is going to be at its x value 1. To find its y value, all we have to do is plug it into our equation right here, and we get its y value. So its vertex is going to be at 1, and then we'll have 4 times 1 squared minus 8 times 1 plus 3. So I get 4 minus 8 plus 3, so I get, what, a negative 1? Yeah, so I get a negative 1. So my vertex is at 1, negative 1. 1, negative 1 right here. All right, and what we're talking about the axis of symmetry means that this equation is going to be symmetric to the line x equals 1, because that's what we came up with right here as our axis of symmetry. So what we know now, without having to plug in 2 as an x-coordinate into the equation, we already know that it's symmetric and it's going to be right there at 3. So all we have to do now is connect the dots and we have this thing graphed. So much easier than picking a bunch of points and plotting it. So there's one example. Last thing to talk about real quick, and I'm not going to include inequalities because we've talked about inequalities before, but when we're graphing inequalities, remember that the only difference is if we have a less than or a greater than sign, the line's dashed. If we have a less than or equal to sign and a greater than or equal to sign, the line is solid when we're graphing it. And then the last thing, there's 2 things that change, whether it's solid or dashed, and then you also have to shade. And we've talked about that before. Last thing to talk about, however, is called the discriminant, and this makes a lot of sense. If we're using the quadratic formula, and you know the quadratic formula is negative b plus or minus a square root of b squared minus 4 times a times c, all over 2a. The discriminant is what's inside of the square root. And we all know that we cannot take a square root of a negative number. If you do that in your calculator, you're going to get an error. It's called an imaginary number. So what the discriminant is saying is, well, if we get a positive number, we're going to have 2 roots, 2 distinct roots, 2 roots for our graph. If we get inside of here to be 0, we're going to have exactly 1 root. And if we get it to be less than 0, so it's negative, we're not going to have a root at all. It's not going to cross the x-axis. All right. So this says determine the discriminant and find the roots, then graph. So determine the discriminant would be negative b, it would be b squared, so 36 minus 4 times a, which is 1, times c, which is 13. So I have 36 and I have 4 times 13, which is going to be bigger than 36, which is going to be 52. So my discriminant is 36 minus 52, which is a negative, let's see here, negative 16. So since it's less than that, I'm not going to have any x-intercepts. I'm not going to have any roots because it's a negative value underneath my square root. I cannot take the square root of that. So I'm going to have to graph this without any roots, which isn't a big deal. The nice part about it is we can still find its y-intercept. Its y-intercept is where x equals 0. So plug in 0 for x and we get 13. So we have 0, 13 as a graph. That's way off my graph up here. The next nice part is we know how to find the axis of symmetry, and from that we know how to find its vertex. So its axis of symmetry is going to be negative b, so 6, all over 2a, which would be 2 times 1. Our a is just 1. And we get, let's see, we get 3. So at x equal to 3, we're going to have our vertex and our axis of symmetry. So it's symmetric to this line right here. And our vertex is going to be wherever, where x equals 3, what is y? So we get 3 squared minus 6 times 3 plus 13. So we get 9 minus 18 plus 13. Well, this is negative 5, so 4. So 3, 4 is going to be our vertex, 3, 4. We know from our end behavior stuff that the thing's going to be pointing upwards like this because that first coefficient isn't negative, so it's going to be pointing upwards. And we know because of this axis of symmetry that we can just, let's pick one point, we'll be able to double it to the other side because we can mirror it over. So we can pick 4. We plug 4 in, we'll get 4 squared, which is 16 minus 24 plus 13. 16 and 13 is 29, and 29 minus 24 is 5. So we get 4, 5 right here. And when we cross that over the line of symmetry. It's got to be right here, so we don't have to plug 2 in. If we plug 1 in, we'll be able to flip it over for our line of symmetry. We plug 1 in, 1 squared is 1 minus 6 times 1, which is 6, 13. So I have a negative, or so I get 7 here and 8. So 1, 8, 6, 7, 8 up here, and we know the line of symmetry, so it's 1 two-way, 1 two-way, 8 as well. So that's how we graph that equation right there. And that's all I have for you. Sorry this took so long, but we had some algebra review to do. I hope this helps, and if not, go ahead and rewatch, and then we'll see you in class for any questions.